Hi and welcome to the third part of my Morse Code Keyer video. Now this is a Morse Code Keyer and this is the user port card that we use to connect this little device to Commodore 64. Now the last time we wrote a little bit of assembly code and we detected the short and long signals. So these are short signals and these are long signals. Now it's time to go a bit further and try to decode those signals or messages back to the letters. So for that we are going to use this little Morse Code chart and we are going to decode the letters only. But I will show you how I mapped this little chart and created a lookup table that we are going to use in assembly code to decode those signals back to the letters. So if you haven't watched the first two parts, I will put the links in the description of this video down below. And now let's continue with our assembly code. Okay, so now I developed this code to actually detect the letters. So the sequence of the signals will produce or will try to detect which letter is in question. So we'll take a look at the Morse code table to see how each of these letters is signals for each of these letters that we're going to use, and I implemented only letters, not numbers or any other characters. So this is just for demonstration purposes, so yeah, just letters. So we have two new variables here. One is a position in our lookup table, so I developed lookup table for our letters, and the other one is letter itself. So this is where we're going to store Petsky character for the letter. That's basically it. And we will do this on the fly. So there is no storage for the sequence of signals. As soon as we receive the signal, we will try to detect which letter that is. That's basically it. And I will try to explain how that works and how I developed or build that lookup table. But for now, let's try to continue with our code, and then I probably will jump in a certain point and try to explain all of that. So yeah, so far here we have nothing new, everything stays the same. We define our interrupt routine. Here we setting up our counter to 8000 hex, and we are setting our position to 0. That's basically it. Now this position variable is used that we know at which position we are in the lookup table as the signals arrive. Again, we have the same main loop when we have our delay 16-bit counter, and once we reach 8000 hex, and we will jump to the next line. But before that, we are going to print out the letter that we detected or we received on the screen. So after each of those signals, dashes and dots, we will print out the letter that we think that those signals represent, and then we will switch to the next line. That's basically it. And all I've done here, just for sanity, I made a little routine for the next line, jumping to the next line. So this is just, it's the same code, it's just routine, that's it. Okay, after we've done that, so we print our letter, we jump to the new line, and then we are resetting our position variable or position counter to 0. We will receive the new signal a new signals which should represent the new letter, and we are starting from 0. That's basically it. Again, we are checking whether or not the user pressed the key space bar on the keyboard. If it did, we are ending our program, and we are stopping NMI interrupt, and we are exiting the program here on line 295. I'm just, yeah, maybe I should zoom in a little bit more. Yeah, okay. Okay, this is now our interrupt routine. Again, it's same as before. We have our counter, we have everything here. Of course, these values can be different because I change them on the fly. The way depends how I crank up that speedometer on the keyer. Again, we are detecting dots and dashes, but this time, after we detected that our PB0 went low, so that means the signal has stopped, we determine whether that's dot or it's dash, so we know that. And then we are jumping at the new routine, which is called locate. And this is the routine where we try to figure out which letter that represents. And everything else here is the same. We are still, once we detect that letter, we will do nothing with it. We'll just store it in that variable. It's LTT variable. So that letter will be stored there, and that's it. But what we are going to do is we need to print our character of dot or dash on the screen, and we are resetting our main counter. We are acknowledging interrupt, and we are exiting our interrupt routine. So far everything is the same, except we have additional routine locate, and I will now talk a little bit about that as well. And this is that routine at line 600. It's not too complicated, but I need to show you how did I create my lookup table and what have I done to make my life a bit easier. But just to take a little peek, this is my lookup table, and these are the corresponding letters for that sequence of codes. Okay, so before I explain my locate routine to detect which letter did we receive, let's take a look at that. Let's take a look at the Morse code alphabet and how it's constructed, and the way how I build my lookup table. So yeah. Okay, so this is our Morse code chart, or Morse code alphabet, at least for the letters, right? So how do we read this chart? Well, we start from this position, and depending what letter do we want to send, we just follow the line. So for instance, let's say that we want to send letter Z. It should go dash dash dot dot, and that should represent letter Z. Also, let's say for the O, dash 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 should give us letter O. Let's try the other side. Let's try letter F. So it should be dot dot dash dot. That's basically it. You just follow these lines, and let's say for the P letter should be dot dash dash dot, and that should give us letter P. So from this chart I created my lookup table. So let me show you that. So here it is. Now I will try to do a comparison. I hope that you will see this. Yeah, I think you will. Okay, so this is my lookup table, and if you take a look at this chart, you will see the most distant letters all have maximum up to 4 signals, right? So what I've done is I map that each row has up to 4 bytes, right? So what I've done, simply follow the first line here, and I map it, as you can see, dot, dash, that's A, dot is E, dash is A, and then we have dot, which is R, and another dot, which is L. And then we start again. We have E as a dot, then dash as A, then we have another dash, that's W, and then a dot is a P, and then we have the same situation, except this time we have J in the end. So that's how I map this whole chart. This lookup table does have a little bit overhead, like you see. First letter definitely repeats several times, same on the other side for letter T, but it should make our life easier in the assembly, and this is how this should work. So for instance, let's say that we receive a list of signals for the letter J. Okay, so we are starting at this position 0 here. And firstly, sorry, I forgot to mention, I did this so that I can do this on the fly. As we receive the signals, I can jump through this table and find the corresponding letter. I didn't want to store these signals in some kind of arrays and then check that later. It sounds just a bit too complicated. So yeah, I want to do this on the fly. As we receive the signal, we are jumping through this table. So okay, we received dot and we are at the letter A, which is correct. In case this is the only signal, we are at the good letter. So the next thing we do, we receive a dash, right? So after this, I receive the second signal. I move in +1 column, and I check whether or not this signal that we receive correspond to this signal here, or dash to dash. Okay, so we did receive dash. Now, secondly, we receive another dash. Now that should give us letter W, but in my row here, when I move one column +1, I have dot. So in this case, I don't have matching signals. In that case, I'm doing +4, jumping +4. That means that I'm going to jump into next row. This is this side, +4. And now we are jumping here at this position, and now we have dash, which represent W. And this is all correct. If our signals stop at this point, we have correct letter. But we receive another dash, right? And we are at this row, so we are jumping here, and now here we have a dot, but we receive the dash. In that case, we are again jumping, or let's say here, +4, and now we have letter J, which is correct answer. And this is how I jump through this table, depending for each received signal. I move one column to the right, and if I don't find matching signal, or that dot or dash, then I progress forward into the next row. And that's basically it. Of course, this is not perfect because I don't have error checksum. This could produce incorrect decoding. So for instance, if we receive incorrect sequence of signals which is not in this chart, my code will end up somewhere in this table and will say, yeah, you received R, but you didn't. But yeah, unfortunately, for this demonstration purposes, this is good enough. And like I mentioned, the whole point of this lookup table is just to make things easy on assembly side. That's it. So yeah, let's progress forward. Okay, we are back at this locate routine again, because just for the sanity and to play safe, right, Again, we are pushing the values from our registers and the accumulator onto the stack, and we will return those before we exit this routine, just to be sure. Okay, the first thing that we do is we are loading the current position in the table in the X register, and from our lookup table we are loading that position into accumulator. So that means that we are going to load from this table here, from this set of data, we are going to load one of these values, right? So we are starting from 0 and we progress +1 and +1. Okay, so we are loading the first 0 position because our at the beginning our variable position is 0, so we are loading that first byte, and we are comparing it to the character that we receive, whether it's dot or dash, again the hex number that's stored in this variable here. If it's equal, we are done. We are doing absolutely nothing else. We will not progress through our lookup table no more. That code represents the same code that we received. That's okay. If not, then we are transferring X value of X register, which is our position, to the accumulator. There we will add 4, so we will jump into the next line. So that means that if we are at position 0, we are going to jump through these first byte here. If we are at position 1, we will loop or iterate through these position here, so our column will always be the same, the position of our column, right? So we are adding 4 to this value, and we are transferring the value of accumulator back to the X register. We are jumping back to our comparison code here. Again, we are comparing the code from the lookup table to the code that we received as a signal, and again until we find the correct code, and then once we done that, so we have equal codes, we will jump to this label LC done, and that's right here. And what this piece of code will do, of course the value X is very important, that is the position that we need, but this time we will load into accumulator not from the lookup table with codes, but with letters. So again, if we are, let's say, here, then we need to load the second byte here, or if we are at the third position here, we need to load third position from our letters table, so it should be letter R. So that means that if we receive dot dash dot, so this sequence of signals, we should print out letter R on the screen. That's basically it. So once we determine the correct, we found the position, then we load that same position from the letters table or sequence of bytes. That's basically it. And we're storing that into variable LTT. That's it. Once we've done that, we are incrementing our X register and storing it into the variable position. So we are doing that because once we detected the first byte, we need to progress further because we received a new signal, and we progress further into the next column. That's basically it. And yeah, we are kind of lucky here because I choose only letters, and letters only have up to the 4 sequence of signals, so it's a bit easier. Yeah, and that's basically it. Once our interrupt routine is done, as soon as we reach, we don't receive any more signals, it's time to switch to the new line, but before that we will just print out that letter on the screen. That's basically. And that's the whole code. So this is our code. And of course, it is possible to send incorrect sequence of signals and still get some letter, because I haven't implemented any checksum or anything else. This is just really simplified as much as I could simplify it. Yeah, just for the demonstration purposes, but that's it. So yeah, let's take a look how this code works now.
Okay, again back with the Commodore 64 and the Morse Code Keyer, this time with the improved code that should give us letters. So yeah, load Viking 4.8 and let's list it. Yeah, that's it. And our lookup table is right here. So let's try to assemble this one. Yeah, all three passes are fine. And 4096, yeah, that's correct. Okay, so if I press O2 and see, it's decoded into letter I. And that's T. I don't know what that is. I. Why is that I? 2, 3 is S. R. That's V. I need to slow the... Oh, that's too slow. I. That's T again. R. S. That's O. Okay, so I have a little Morse code chart. So according to this, I should be able now send some kind of message. So let's say that I want to send J. Where's the J? J is dot dash dash dash. So dot dash dash dash. That's J. Then we have R. R is dash. Sorry, dot dash dot. Dot. Oh, bloody hell! Dash. Dot, that's R. And B is dash dot 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 dash. Yeah. So let's try to send hello. So 4 dots. Oh, it's H. 1 dot. That's E. Then L. We need L. Where is the L? So dot dash dot dot dot. Bloody hell. Dot dash dot dot. And then again dot dash and O, and that's just 3 dashes. Oh, Halo, Halo. Well, there you go, Halo, or hello, whatever. Yeah, that's our Morse code decoder. But I cannot do this fast. This is. Oh, come on. What's that? H. Yeah. Like I mentioned before, my lookup table is not perfect. It works if you send correct signal, but so Y, E. So we have dot, and then dash, and then dash, that's W. And then dot, that's P. And then dot and it's switch to the next row. Yeah, that's not good. Maybe I should improve my. Let's go one more time. H, and then we need one E. Then we need L, which is dot L, and O is 3 dashes. Finally, hello. Okay, so oh well, this is the fun part. Okay, I'm done. I'm done. Okay, well, this is all that I have for you in this video, and I hope that you like it. Well, it's fun to play with this. So until next time, goodbye.